We talk a lot about how incredible AI models are, but we almost never talk about what it physically takes to power them. The AI revolution, it's not just happening in the cloud. It's a massive global construction project. So today, let's pull back the curtain on this hidden world of AI infrastructure.
And that really brings us to the core question of this whole explainer. What is the true cost of AI? And I'm not talking about your monthly subscription fee. I'm talking about the raw, physical resources it takes just to ask a large language model a single question. The answer, it turns out, is all about energy.
Okay, get ready for a number that's, it's pretty staggering. By 2026, data centers are projected to consume 1,000 terawatt hours of electricity every single year. To put that in perspective for you, that's almost 3% of all the electricity generated on the entire planet. This isn't just some small uptick. No, this kind of demand is literally pushing our electrical grids to the breaking point. And of course, where there's that kind of demand, you're going to see a ton of investment. The big tech hyperscalers, companies like Google, Microsoft, and Amazon that operate on a crazy global scale, they're planning to spend over $325 billion on data center construction in 2025 alone. This isn't just a trend, it's an absolute explosion. It's really like a modern gold rush. But think about it. Who got rich in the original gold rushes? Yeah, a few lucky prospectors, sure. But the real, lasting fortunes? They were made by the folks selling the picks and shovels. And it's the exact same thing today. The gold is the flashy AI models, but the picks and shovels? Well, that's the cooling systems, the power solutions, and the software that actually make it all possible. So this race to power AI is really being fought on a few key fronts. You've got cooling, energy, and software as the big ones. But as we're about to see, grid optimization plays a huge role too. This is where all the innovation is happening, and it's where companies are battling it out to solve AI's massive energy problem. And this chart right here, it basically maps out that entire battlefield for us. Let's just break it down real quick. So that horizontal axis at the bottom shows you how mature a company is, from the brand new startups on the left all the way to the established public giants on the right. Then the vertical axis on the left shows what they focus on: cooling, renewable energy, the grid, and software. We're going to use this map to navigate the key players, and we'll start with those giants on the far right. All right, so let's start over on the right side of that map with the big, established public companies. These are the giants who are already building out solutions at a massive scale to try and meet today's insane demand. First up is Vertiv. Honestly, if you're looking for the most defensible public company in this whole space, this is probably it. AI chips get incredibly hot. So hot, in fact, that your typical air conditioning just can't keep up anymore. It doesn't work. Vertiv is the leader in thermal management, which means they're creating these industrial-strength cooling systems built for the AI era. And the demand for what they're selling is just surging. Just look at their numbers from the first quarter of 2025. Revenue, new orders, their backlog of future work, it's all up by more than 20%. These aren't just good numbers. They're a massive signal that Vertiv has become an absolutely mission-critical supplier in this whole AI build-out. Now, this slide is where you can really see the technological leap we're talking about. Look at that first row, rack density. That's just a fancy way of saying how much computing power you can cram into a single server cabinet. Traditionally, you were limited to about 8 kilowatts, but check out the jump with Vertiv's liquid cooling, over 50 kilowatts. You can pack way, way more computing power into the same space, all while drastically cutting the amount of energy wasted on cooling. It's a game changer. Okay, so our next giant, IREN, is coming at this from a completely different angle. Instead of just selling the equipment, they're building the entire infrastructure and then profiting from it. They actually got their start in Bitcoin mining, where the only way to survive is to secure the absolute cheapest electricity possible. And all that experience gave them a huge competitive advantage. Get this, they can source 100% renewable energy for just over 3 cents per kilowatt hour. That is profoundly cheap, like a third of what it costs in most of the US. And they do it by owning or controlling the renewable energy assets themselves. And if you want proof that their model works, well, here it is. A nearly $10 billion contract with Microsoft to provide AI infrastructure. This one deal is all the validation they need. It proves their model works at the highest level, and it gives them the cash to expand without having to go back to investors for more money. Okay, so let's shift gears from the giants to the disruptors.
We're moving to the left on our map now into the world of venture-backed startups. These are the companies inventing the next generation of solutions. And honestly, they're completely changing the game for data center efficiency. So that cooling problem we talked about, it's attracting some of the most creative minds out there, and they all have a unique angle. For instance, ZutaCore is putting cooling liquid directly onto the chip. Then you have a company like Phasic Energy, which is trying to capture all that waste heat and literally turn it back into electricity. Coolest DC is tailoring its solutions just for the hot, humid Asian market. And Immersion 4 is taking maybe the most radical approach of all. They're just dunking entire servers into non-conductive fluid. Wild stuff.
Let's just focus on ZutaCore for a second so you can really get the scale of these improvements. Their tech allows for 10 times the compute density while using half the energy for cooling. These are not small incremental gains, you guys. These are fundamental breakthroughs.
And this innovation is happening absolutely everywhere. Over in energy, you've got Intersect Power building massive solar farms right next to the data centers. So Luna has this really clever model where they find stranded renewable energy, like a wind farm in a remote area with no power lines, and they just put a data center right there. In software, companies like Moat and RidTech are using AI to make existing data centers 5 to 15% more efficient. And even on the grid itself, Daylight Energy is using crypto economics to network home batteries together to create a virtual power plant to support the grid. So, with all this innovation and all this money flying around, it's really easy to get caught up in the hype. But it is so important to take a step back and have a balanced look at both the massive opportunity and the very, very real risks that are involved here.
I mean, the bull case is pretty clear, right? This is essential infrastructure for the next decade of tech, and it's a $300 billion plus market. The first companies to solve these problems are building some powerful competitive advantages. But the bear case is just as real. Let's be honest, building this stuff is incredibly hard. Supply chains are fragile, and you always have the threat of a big competitor entering the market and squeezing your profits. So the key takeaway here is that while the opportunity is historic, success is definitely not guaranteed. So what's the big picture here? What's the main takeaway from all of this? Well, when you zoom out, you start to see something a lot more profound than just a bunch of individual companies. What you're really seeing is a system-wide revolution in how we power computation itself. Think about it. The greatest technological shifts are almost never about one single invention, one magic bullet. They're about entire systems evolving together. The future of AI isn't going to be solved by just a better cooling system or a new power source. No, it's going to be about the integration of cooling, energy, software, and grid innovations all working together in concert. Which leaves us with one last kind of provocative thought to chew on. For all our talk about amazing algorithms and processing power, is it possible that the ultimate speed limit of artificial intelligence won't be set by code, but by the physical limits of cooling pipes and power lines? Something to think about.